All right, 8D, polynomial division. Okay, so this is another way of being able to solve things. So like we saw or see there in that little meme, we're going to kick it back to elementary school and do some like 3rd grade, 4th grade, I don't know what grade it is, long division. Okay, so if I want to divide 1732 by 5, let's see if you remember this. I got to see how many times 5 goes into 1, and it doesn't, so I would move it to 17. So how many times does 5 go into 17? That would be 3 times. 3 times 5 is 15, and then I would subtract these. 17 minus 15 is 2, and I bring that number down. 5 goes into 23 4 times. 4 times 5 is 20. I subtract them and bring that number down. 5 goes into 32 6 times. 6 times 5 is 30. Subtract them, and so my remainder is 2. Alright, you remember that? We're going to do that same process, but we're going to do it with polynomials. Okay, so I'm going to take this 4x squared plus 23x minus 16, and I'm going to divide by x plus 5. Okay, so we're just going to look at this first term. So I need how many times x would go into 4x squared? Or, put it another way, what do I need to multiply x by to get 4x squared as the answer? Well, that would be 4x. Alright, and so then I multiply this 4x by both things here. So 4x times x is 4x squared. 4x times 5 is 20x, and then I am subtracting these things, and that is very important because people forget. So 4x squared minus 4x squared is 0. Those cancel each other out. 23x minus 20x is 3x, and I'm going to bring that negative 16 down. Okay, so now I'm looking at x going into 3x, and so I'm going to multiply there by 3. 3 times x is 3x. 3 times 5 is 15. Okay, and remember that we are subtracting here, so 3x minus 3x would cancel out. Negative 16 minus 15 is going to be negative 31, and that's going to be my remainder. Okay, so 4x plus 3, and then negative 31 is my remainder. Alright, and then when we write it factored, we're going to write what we divided by, so x plus 5, and then what we got, which is 4x plus 3, and then our remainder is minus 31 over x plus 5, because that's what we divided by. Alright, and that's polynomial long division. So I want you to pause here and try example 2 on your own, and then come back and check, see what you got the same thing I did. Alright, so you should have gotten 3x minus 8 with no remainder. Okay, here's the big thing that people mess up all the time. Remember that this minus, okay, goes with both of these. So 3x squared minus 3x squared, they cancel. Then this is negative 29x minus negative 21x. Okay, so that is essentially negative 29 plus 21. So that's where I got this 8x from right there. So that is a very common mistake. So you're going to need to make sure you're paying attention on that second term, and it's minus whatever is here. Okay, now there is a second way to do division. It's called synthetic division. Alright, but the trick with synthetic division is you can only use it if the degree of what you're dividing by is 1. So you can only use it if this is just x. If you have x squared or x cubed or anything like that, you can't use it. So for synthetic division, ooh, that was not a good straight line. Let me fix it. Okay, I'm going to draw this sort of L shape, and up top here I'm going to put just the coefficients. So we don't really care about the letters, but just the coefficients. So I have 1, negative 14, 51, negative 54. And then over here I'm going to put what my divisor is here. I'm going to set that equal to 0. All right, and so x would be equal to -2. That's what I'm going to put right here. So here's how synthetic division works. We take this 1 and we just drop it down here. And now I'm going to multiply by this number. So -2 times 1 is -2. All right, and I add these two things together. So this is -16, and then I multiply by this number again. So it's always times this number. So -2 times -16 is +32. And I add them together, so that would be 83. And then 83 times -2 is -166. And I add those two together, and I get -220. So when in synthetic division, whatever this last number here, that is your remainder every time. Okay, and then we work backwards. This is a constant, so it's just number. This would be just x, and this would be x squared. So my answer here would be x squared minus 16x plus 83. And then I have the remainder, so minus 220 over x plus 2 is my remainder. Okay, so let's go through another one. I'm going to take the coefficients. So now this one is an example of sort of the trick when we're doing division. We have x cubed minus 57x plus 56. And all of our divisions require that these go in order. So it would be to the third power to the second power to the first power. But this one doesn't have an x squared term. So what we're going to do is put in a placeholder of plus 0x squared. Okay, I have to have a place in there for every degree going down. So when I write my coefficients, I'm going to write 1 and then 0 because there's no x squared term, -57, and then positive 56. Okay, x minus 7 equals 0, so x equals 7. That's my number that's going to go here. All right, bring my 1 straight down, multiply by 7. 7 times 1 is 7. 0 plus 7 is 7. 7 times 7 is 49. And -57 plus 49 is -8. 7 times -8 is -56. 56 plus -56 is 0. So that means this one has no remainder. All right. -8 is my constant. Okay. 7 is my x term. And then this one is my x squared term. All right. So this is the answer to my synthetic division there. All right, last thing we're going to look at is using synthetic division to make it easier to find zeros. So when we do this, here's our equation, and it's a 5th degree, so it's got a lot of terms. And the first thing we're going to do is graph it in our calculator and find any roots that we can using the calculator. Alright, so I graphed that here on my calculator and did gsolve root and found these 3 roots, and it's -2, 1, and 2. Okay, but we know from last lesson, the fundamental theorem of algebra, that because this is a 5th degree, this needs to have at least 5 roots. So there's 2 more that we need to find. So what we're going to do is, knowing these 3 roots, we can use synthetic division to do what's called depressing the polynomial. It doesn't mean to make it sad. Okay, it means we're going to take these factors out of it, and it makes the math kind of easy to do it with synthetic division, so that we can then find the last 2 using the quadratic formula. So what I'm going to do is take this, and let me make sure 5, 4, 3, 2, 1. So I don't need any placeholders. Okay, so my coefficients are 1, -1, -3, 3, -4, 4. Okay, and I'm going to take my first root here that I found, and I got x equals -2. Okay, so I'm going to divide by that. So bring my 1 down. Okay, this is a synthetic division process. Remember, I multiply by this number, so this one is -2. Those added together are -3. Times -2 is +6. Add those together, I get 3. Times -2 is -6. Add those together, I get -3. times negative 2 would be positive 6. That leaves me with 2 here, times negative 2 is negative 4, and so I have a remainder of 0. So now what I've done is factored out that negative 2 so that now I have a smaller polynomial, and we're going to factor these two out as well. So I'm going to take my answer. Alright, so 1, negative 3, 3, negative 3, 2, and now I don't need that 0. And now I'm going to factor out this root, this 1. Alright, so bring my 1 down, times 1 is 1. Those add to negative 2, times 1 is negative 2. That adds to positive 1, times 1 is 1. That gives me negative 2, times 1 is negative 2, and that's 0. Alright, so again, we got rid of one more factor, and now I'm going to take my answer again, and I don't need the 0. And I'm going to factor out this root, so that's a 2. Alright, so bring my 1 down, times 2 is 2. Add those together is 0, times 2 is 0. Add those together is 1, times 2 is 2. Add those together is 0. So what that means is I have x squared plus 0x plus 1. If I factored these three roots out, that's my remaining polynomial. Alright, and I'm going to solve this using the quadratic formula. So a is 1, b is 0, and c is 1. Alright, so my quadratic formula, I get the square root of negative 4. 4 is a perfect square, so that's 2, and then I, because it's negative, these 2's cancel out, so plus or minus I are the last two roots. So all of the roots of this polynomial would be negative 2, 1, positive 2, negative I, and also positive I. So there's my 5 roots, 3 real ones, and 2 imaginary.